Next, though, we have one without a common denominator. Alright, so let's learn the trick we used earlier. Let's say 3 over 4 and 1 over 5. Now, some of you might know that the common denominator is 20, but let's go ahead and go on out. Some of these are real big. You might end up having to go several spaces out, but I can tell we won't have to go too far out on this one. Let's do multiples of 4. Let's say 8, 12, 16, 20, and 24. And let's go ahead and do 3. We have 3, 6, 9, 12, 15, 18. Multiples of 5, 5, 10, 15, 20. Oh, and I found one right there. Let's go ahead and do multiples of 1, though, because we have to do that. 2, 3, and 4. And so we can circle these right here. 3 over 4 is the same as 15 over 20, and we know 4 over 12, or 4 over 20 is the same thing as 1/5. So let's make sure we rewrite it correctly. Now we've got 15 over 20 minus 4 over 20. And remember, we don't have to worry about the math on the bottom anymore. All we have to worry about is on top. So we know, let's get rid of all that. We know that 20 is going to be on bottom. We say 15 minus 4, and that will be 11. Yeah, 11. And 11 over 20 does not reduce. Now, unfortunately, we do have some like this. We've got a small fraction and then a bigger one. So our answer is going to be negative. This is very, very similar to what we did last week. So what you need to do is find your common denominator, and let's use our trick like we did earlier. I'm going to go ahead and tell you that the common denominator is 25. So we're going to end up being 5 will go into 25 5 times, so we have to, since we multiplied this by 5, we have to multiply this by 5. So it's going to be 10 over 25 minus 21 over 25. Uh-oh, I don't know what to do here. Well, remember what we said, the math on bottom is done. It's going to be a positive 25 or just a 25, so 25 on bottom there. Now we're left with what? We're left with 10 minus 21. And let's rewrite that out. 10 minus 21. Mr. Camp, I don't like those. I don't understand that concept. I don't understand the concept that if it's 10 degrees outside, I lower my temperature by 21, that my new answer is negative 11. Well, if we have a subtraction problem, we can keep, change, and flip, make it addition, and apply our song. So we can keep this 10, mark it out. Let's change this minus sign to a plus sign, mark it out. And we're left with just 21. We're going to keep, change, and change, or keep, change, and flip. This is going to be a negative 21. Now I've got same signs, add and keep, different signs, subtract. Well, these are different signs, so I'm going to subtract. I'm going to say 21 minus 10 is 11. Take the sign of the farthest number, which is negative 21, negative 11. Now our answer is negative 11 over 25. Okay? And sometimes they're going to be easy for us. Sometimes we're going to have the same common denominator. All right, this is difficult. This is a little bit more easy. We know our bottom is going to be 3, but our top is 1 minus 2. And that's going to be a negative 1. And if you apply that, keep, change, and flip to that, and then apply our addition song, once you made it an addition problem, we'll know the answer is negative 1/3. And it doesn't matter if you put the minus sign here or out here, but it's still negative. And remember, if you have an answer that is negative, you must write. You must write it as negative, or otherwise I have to count it wrong. Now, here, this subtraction problem is going to combine everything that we've known about integer rules and adding and subtracting positive and negative numbers. It's going to combine everything we've known about finding a common denominator. And we're going to add one more step to it, because what we have right now is a mixed number, and that's very, very difficult for us to add and subtract those. The first thing we need to find, and this is one of those 3 or 4 minute problems, maybe a 5 or 6 minute problem, is we need to find a common denominator. We need to find a common denominator. Before we turn it into a mixed number, let's go ahead and find or excuse me, before we turn it into an improper fraction, we need to find a common denominator. And let's just deal with the fractions for right now. I've got 7 over 12, and I've got 11 over 15. Let's do a few multiples of each. And guys, you're really going to have to think on this one, okay, because this one's very, very hard. We have multiple steps. We have 12, 24, 36, 48, 60, 72. Well, let's keep going. I got 15, 30, 45, 60. Oh, I found it. Here we go. So let's just go ahead and do our multiples of 7. I got 14, 21, 28, and 35. That one's going to go here. Then I've got 22, 33, and 44. So now my new problem is this. I'm going to have 4 and 35 over 60 minus 7 and 44 over 60. Now, we still got a ton of math to do because I got to change that now into an improper fraction. And you're not going to have a whole ton of these that are like this, but you will see it. An improper fraction, how we do that is multiply this, the denominator, times the whole number, and then add the 35. So in this case, we got to say 60 times 4 is 240 plus 35 equals 275. So we keep that number and we place it over 60. So I got 275 over 60 minus. Okay. Well, we do the same thing over here. 60 times 7 plus 44. 60 times 7 is 240 plus 44 is 288. So now we have, and that should be a 60, sorry. This will be a 60. I've got 288 over here. Well, now this is my new problem. Okay. Don't worry about the math on bottom. The bottom is done. We know that the numerator is going to be 60. Now all we have to do is say 275. 240 plus 35. Oh, I'm sorry, I messed up my math. Please forgive me. This is 240 or 420 plus 44. You'll have to forgive me. That's going to be 420 plus 44 equals 464. Okay. Remember, the bottom's done. So now all we're left with is 275 minus 440 or 464. 275 minus 464. I'm going to double check my math again before I make it boo-boo. Okay. Well, Mr. Camp, I don't like taking a small number and subtracting a bigger number from it. Well, let's do keep, change, and flip, make it addition. Then we can sing our song. I'm going to keep, change, and flip. Same signs add and keep, different signs subtract. So we're going to subtract. Sorry, I'm all over the place here, but 464 minus 275. This becomes a 14. Bar from here makes that a 5. 14 minus 5 is 9. 5 minus 7, well, that doesn't work. We're going to have to make that a 15, make that an 8. Bar from here, make that a 3. 3 minus 2 is 1. So now I'm left with 189 over 60. 189 over 60. But I'm supposed to take the sign of the farthest number, and this one's farthest from 0, so it's going to be negative. Negative. Well, this is always incorrect form. This is an improper fraction. We have to change it back. We have to change it back to a mixed number. And how we do that is 189 over 60 is simply 60 into 189. 60 will go into 189 3 times without going over, which leaves us 180 with a 9 remainder. So the answer is 3 with a 9 remainder over 60, which should reduce to, let's see, it looks like 3 will go into both of those, so 3 and 3 over 20 negative. Before we move on, I'm going to check my math. That's it. Negative 3 and 3 over 20. Again, that's a very, very long problem, which started out right here. But if you follow those steps, you'll be just fine. And again, forgive my math here, but if you redo this over and over, you'll see what I'm talking about. Now, let's move on to what a fraction actually is. Let's talk about fractions in a little bit more detail. What is 7 over 12 written as a decimal? Well, what is 7 over 12? 7 over 12 is nothing more than 7 divided by 12. 7 over 12 is less than 1. It's a fraction. It's a fraction. Just think about the fraction of a pizza. If you have a pizza cut in to 12 slices and you take 7 of them, you have 7/12 of that. You do not have the whole pizza. Now, at some point, you're going to go on and on and on and on with these if you're not, you know, if you're paying attention. So this is going to be 12 into 7. And let's be sure and we know where our number is. It's 12 is not going to go into 7, but it will go into 70. It'll go in there. I tell you what, let me rewrite this up here. 12 into 7.000. Let's go ahead and add several zeros just to make sure. Okay. And let's bring our decimal up. Well, 12 won't go into 7, but it will go into 70. It'll go 5 times without going over. And this is 60 with a remainder of 10. And bring down our 0. 12 will go into 100 without going over 8 times. 8 times 12 is 96. Remainder 4. And bringing down our 0 again. And what you're going to see is you're going to keep getting that number, and you're going to get what is called a repeating decimal. Alright, and that is the way you figure out how what a decimal is written in decimal form. You divide the top by the bottom. Remember, top dog goes in the house. Goes in the dividing house. Again, you would do the same thing here. 8 into 1.000. Bring up our decimal. 8 will go into 10 one time without going over because it won't go into 1. We got 8 left over and 2 and so on, and the answer is going to be 8.25. We would do the same thing with 1 over 4 written as a decimal, but we should at this point know that. We should know that that's 0.25. Now, if we divide 3 into 1, what you're going to find is we're going to continue to get 3's here. 3 will go into 10 3 times. 3 is 9. You're going to keep getting this 1 into 10 here. That's that 3, 9, 1. Bring down your 0 again. 3 into 3 and so on. That's going to keep going. That's called a repeating decimal. This 0.25, on the other hand, is called a terminating decimal. Think about the Terminator. The Terminator ends things. You terminated your contract with somebody or something like that. It means it does end. And again, we would do the same thing with 1 over 8. That is 0.125. And I guess we already did that one here. Now, which fraction below can be expressed as a terminating decimal? In other words, which one is going to end? Which one at some point will end? Well, I've got 1 over 3 is point, and I'll just save you the suspense, 0.3333 infinity. 1 over 4 is 0.25. 8 over 9 is 0.8888 infinity. And 2/3 is 0.6666 infinity. Which one of these is terminating? In other words, which one ends? Right there. And by the way, if a bunch of zeros, that does not count. Another hint I want to give you, anything over 9 is that number repeated. So if I have 7 over 9, that is 0.7777 infinity. Which fraction below can be expressed as repeating? Well, let's take a look at them. I'll just save you the time. Normally you have to go through the long process of dividing these, but I'll just show you. This is 0.666 infinity. It looks like we got a winner. This is 0.1 or 1 over 12 is 0.8, I believe, or 0.8333. So actually this one can be repeating too. This one's 0.125. That one is not repeating. And 2 over 5 is 0.4. That is not repeating. So there we go. Again, what is 5 over 9 written as a decimal? 0.5555. The best thing for you to do is start to memorize what some of these are so you don't have to do so much math. This is 0.5 right here. This is 0.25. And this is 0.555. And so on and so forth. This is 0.375. Okay? Which one cannot be a terminating decimal? Which one does not terminate? In other words, well, this one goes on forever. This is it. So a terminating decimal at some point ends. It may be 10 digits, but at some point it ends. I would recommend going out, if you're unsure, going out maybe 3 or 4 places. Again, 2 over 9 is 0.2222 infinity. Is 0.125 considered repeating or terminating? Well, does it terminate or does it continue to repeat? Well, obviously, it terminates. It's terminating. And this 0.333 should have a line over it, or more traditionally, it's written 0.3 with just a line over it. Is it considered repeating or terminating? That should be terminating. This is a repeating decimal. Number 13. What mathematical operation is being performed in 1/3? Well, we have 4 mathematical operations: addition, subtraction, multiplication, and division. We know that a fraction is the same thing as the top dog going in the house, the denominator on the on the outside. This is division. More to come.